It is famously hard to see black holes. I mean, they're called black for a reason. Despite the fact that light can travel at the fastest possible speed through the universe, even it can't escape a black hole's gravitational clutches if it gets too close. And yet, not all black holes are shrouded in darkness. Some of them even manage to outshine an entire galaxy. In fact, there's one black hole that's the size of an entire solar system, and it powers the brightest object in the known universe. That brightest object is what astronomers call a quasar, and quasars are a type of active galactic nucleus. Basically, it's the core of a galaxy that's home to not just any supermassive black hole, but one that is actively devouring a bunch of gas, dust, and so on, even if it has to tear a whole star asunder. And the way astronomers can tell whether or not a black hole is active is by looking at how bright it is. Or rather, how bright all the stuff swirling around the black hole has gotten. Because as matter falls closer and closer to the black hole, it heats up. And when things get hot, they glow. Some of that light gets beamed directly into our telescopes, and some of it gets absorbed by even more matter that's a bit further away from the black hole, which makes it heat up and start glowing too. So altogether, an active galactic nucleus will shine basically all across the electromagnetic spectrum. One rule of thumb is if you've got a galactic core that's 100 times brighter than the rest of the galaxy combined, you're dealing with an active galaxy and its active galactic nucleus. And astronomers love these things, in large part due to their brightness. Or technically their luminosity, because despite sounding like synonyms, those are different things. Luminosity is the amount of energy an object puts out, and brightness is, well, unsurprisingly, how bright the object appears to an observer given how far away it is. Because space is just so darn big, you could have an active galaxy that's way more luminous than a run-of-the-mill galaxy, but it's not brighter in your image because it's a lot further away from you. That being said, astronomers do have a way to report brightness that tries to compensate for different distances. And it's easier to say bright than luminous, so we're gonna stick with that. Anyway, the fact that active galactic nuclei like quasars are so much brighter than non-active galaxies means they are easier to see. And that's especially handy when you're looking farther and farther away, where signals grow dimmer and dimmer. It's why almost all of the galaxies that have tried to claim the title of most distant galaxy are quasars. And together, they're helping astronomers learn about the universe's toddler years. But just because we can see them doesn't mean we understand them. For example, we still don't know how quasars can get so big so quickly. So we have to study them to figure this stuff out. But the problem is, even though they're often the brightest things in their cosmic neighborhoods, quasars can be weirdly hard to find. And that's largely because they don't look like massive galactic cores. They often look like plain old stars. In fact, that's where they get their name. Quasar is short for quasi-stellar radio sources. But that's not to say we can't tell quasars and stars apart, we just have to try a little bit harder.
This SciShow video is supported by Bombas. Bombas makes socks. But if you're not a sock person, they also offer t-shirts and underwear, which happen to be the 3 most requested items in homeless shelters. So for every purchase, Bombas donates an item to people who would otherwise go without. That means when you give Bombas socks as a gift, you're really giving 2 gifts. In the more than 10 years that Bombas has been helping out the community, they've donated over 140 million essential clothing items. And you can be a part of that today. New customers get 20% off their first purchase at bombas.com/scishow using code SciShow at checkout.
Enter SMSS J052915.80-435152.0. It's the brightest quasar ever. This record setter was first spotted by a telescope survey mission in the 80s, but astronomers didn't know it was a quasar until 2023. In all likelihood, that was due to an algorithm that astronomers were using to sort through the huge amounts of data that the telescope was collecting night after night. In other words, the survey didn't have a specific target. It was just staring at a huge swatch of the sky that contains a bunch of different, potentially interesting objects, and astronomers rely on software to help filter out all the stuff that isn't. So the computer probably went something like, well, this can't possibly be a quasar, it's too bright. It must be a foreground star, so don't bother. But thanks to a second look with a different telescope, one team of astronomers managed to uncover its true identity. It wasn't some random photobombing star in the Milky Way, it was a quasar located at a redshift of 3.962. Now, if you're not an astronomer, that doesn't really mean anything, but redshift is a property that reveals how far away other galaxies are, especially galaxies that are really, really far away. You can kind of think of redshift as the Doppler effect, but for light instead of sound. If an object like a galaxy is moving away from us, that motion stretches out the light waves heading in our direction, so they look redder than they otherwise would. And since the universe is not just getting bigger, but getting bigger faster over time, the further away a galaxy is, the more its light gets redshifted, and the higher that redshift number. So if astronomers measured a redshift of 3.962 for our quasar friend here, how far away does that make it? And since it takes time for light to traverse the universe, how old is our picture of this thing? Well, we're not really sure. To translate a redshift into, say, light years, we have to make a few assumptions, like how fast the universe is expanding, and unfortunately, astronomers have, let's say, some conflicting measurements for that. But very roughly, we're seeing this quasar as it looked about 12.8 billion years ago, and when the universe was about 860 million years old. That actually puts it a lot closer to us than other unusually large quasars. Given that distance, it means that as dim as it appears in the sky, it's actually about 500 trillion times brighter than the sun, by which I mean luminous. Nothing else in the known universe is that bright. And to pump out all that light, it requires an active, supermassive black hole that's about 17 billion times the mass of our sun, which is not the most massive black hole we've ever seen, but it's still doing pretty well for itself, because it also appears to be the fastest growing black hole in the universe. Every year, it consumes somewhere between 280 to 490 suns worth of matter. You could average that out and say it eats about one sun per day, which also means it's probably eating off the largest known plate in the universe, if we're calling the accretion disk a plate now. That is a lot of superlatives. Astronomers may eventually uncover another object that's even brighter. Perhaps it's another misidentified quasar just chilling out in some survey data. But in the meantime, they can try to work out exactly how these things are made in the first place. So you might say the future of quasar research is looking pretty luminous, by which I mean bright.